In this lecture, we're going to explore the case where you want to set up a three-way comparison operator for your type, but your type happens to have members that don't implement the three-way comparison operator themselves. Let's try and make this super clear with an example. In the last lecture, we did an item class which defaulted the three-way comparison operator using the syntax here. And this was working just fine because we had only integer member variables. Remember that the int type already supports the three-way comparison operator, and it is going to be doing strong ordering by default. But in this example here, we have another type as our member, and this happens to be integer, a custom class that we have set up in our own C++ code. This is the initial setup for our integer class that we're going to go with in this example. And you see that it doesn't implement any comparison operator. It doesn't have an equals operator. It doesn't have a not equals operator. It doesn't have any of the greater than, less than versions. It doesn't have anything. And the compiler doesn't have any idea of how it's going to compare integer objects. And this is a problem. So if you set up your class like this and you want to have a member that doesn't have any concept of comparison like integer here, this is going to be a problem. The three-way comparison operator that you have defaulted is going to be deleted by the compiler because the compiler is going to realize that it can't really compare the member variables. The integer class doesn't support the three-way comparison, and it doesn't support any kind of comparison whatsoever, so we can't really compare integer objects. The compiler is going to see that you are trying to set up a three-way comparison operator, and it is going to delete this comparison operator here because you can't compare these guys. So you're going to get a compiler error if you try to set up something like this. But a lot of code out there already implements some kind of comparison. Most types are going to support the less than operator or the equals operator. And the designers of C++ saw that if we happen to have these operators in, C++ compilers should try their best and deduce the three-way comparison operator from these two operators. The inspiration again came from the fact that most code out there already has the equals operator and the less than operator. A good example of this is the std_rail_ops namespace we have learned about. This is a namespace that is going to generate all the other operators from the equals operator and the less than operator. This is going to be using a bunch of function templates that you can get access to by including the utility header in your code. We saw that it is possible to generate all the other operators from the equals and less than operator. Okay, so having this in mind, the C++ compiler should really try its best to generate a three-way comparison operator from these comparison operators here. And that's actually the case. Any self-respecting compiler that supports C++20 is going to try and do that. But this is not going to work out of the box. We still need to help the compiler out in specifying the return type of our three-way comparison operator. The reason is because the item class is not going to have any concept of three-way comparison. It doesn't really care about strong ordering, weak ordering, or partial ordering. So we need to help the compiler out and tell it the kind of comparison it would deduce from the comparison operators we have in our integer class. And in this case, we're going to tell the compiler that we want strong ordering, and this is going to work. One thing you should know is that this is not going to work with the current GCC version I have that I am using in this course, but this should change in the future as new versions of GCC are released. I am going to show you that this is going to work on Clang. I think the version I will be using is 11, and this is going to also work on the latest version of Visual Studio that you can get your hands on. So this is something I want you to know. Once we have our operator in, it is going to do whatever we want to do with it. We're going to have our 6 comparison operators, and they are going to work just fine. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is members without spaceship operator. We're going to be reusing the code we had in the last lecture. So let's grab that and use that as our starting point here. This is going to save us a few seconds. And we're going to open our now project in Visual Studio Code by dragging and dropping here. This is going to give us our item class, and we're going to have the code in the main function to use that. Now, what we are going to do is set up another class, and the class is going to be the same integer class we have seen in the slides. And for now, we're going to disable these operators and show you that we're going to get a compiler error if we try to set up a member of this integer type. Let's go back in our item class and actually do that. We're going to put in an integer type. And if we try to go down and look at our code in the main function, we're going to see that it is not working now. The spaceship operator now has problems if we hover over the squiggly lines, or if we bring in a window and see the problems tab, we're going to see that we have a bunch of problems here. The spaceship operator is not working anymore. If we try to build our code with any C++20 supporting compiler, we're going to get compiler errors. Let's do that. We're going to pass our code through GCC first, because that's our favorite compiler. We're going to see that we have a bunch of errors, and the errors are basically saying that the spaceship operator has been deleted. So let's try and analyze what is happening here. The compiler is looking at our item class. It is going to see that we want to set up a default three-way comparison operator. So by this, the compiler is going to know that it needs to do member-wise comparison. So it is going to look at the members we have in the item class. It's going to see A, it's going to see B, it's going to see C. It's going to see that they are of int type, and int already supports the three-way comparison operator. So it can really compare int types without a problem. Then the compiler is going to see that we have a member of type integer, and it is going to look at this integer type, and it is going to see that we don't have any kind of comparison operator here. We don't have the three-way comparison operator. We don't even have an equal or less than operator. So this is going to blow up. The compiler is going to see that you are trying to set up a three-way comparison operator, but we can't really do member-wise comparison because we can't compare integer types, and the compiler is going to delete this three-way comparison operator that you tried to set up. That's why we are seeing the errors we have here, saying that we are trying to call a member function that has been deleted. And you see the error here says use of deleted function, and the function happens to be the three-way comparison operator. This is the problem we have here, and this is not going to work. But a lot of code out there already has the equals and less than operators implemented. The reason is most people are going to expect to implement all the other operators using the equals and less than operator, just like the std_rail_ops namespace is doing in the C++ standard library. So the designers of C++ thought it might be a good idea to try our best in the compilers and really synthesize a three-way comparison operator from these two operators. But that's not going to work at this point either, because the integer type doesn't have the concept of three-way comparison. The compiler won't know which kind of comparison it's going to use. Remember, with three-way comparison, we may support strong ordering, weak ordering, or partial ordering, but the compiler doesn't know what kind of comparison we want to do. So we need to help the compiler out here and specify the kind of ordering that we want for our type, which is item here. And if we go in and specify, for example, std strong ordering as our return type for the three-way comparison operator, most C++20 compilers are going to support this, and this is going to work. But this won't work yet in our current version of GCC. So if we try to build this, we're going to get a compiler error. Let's build this, and we're going to see that we still have the same kind of problem. But if we change our compiler and, for example, use Clang 11, Clang 11 already supports this. you're going to see that the build is going to be good because this is already supported in the version of Clang that I have on my system here. Let's wait for Clang to figure this out. You see that the build is good and we can run our program and get the output that we want. We're going to run Rooster and you're going to see that we're going to compare our objects. This is going to work just fine. If we also build with the latest version of Microsoft Visual Studio, the compiler behind that, this is also going to build fine. You're going to see that if we wait for it, the build is going to be good and we can clear and run Rooster and this is going to work. So this is really something I want you to be aware of. If your type happens to have a member that doesn't implement the three-way comparison operator, by default, you are going to get a compiler error if you try to deduce the return type of your three-way comparison operator using auto like we did before. Let's show you that this is also going to give us an error. If we build with Clang, let's use Clang here. You're going to see that we're going to have the same kind of compiler error. We are using a deleted three-way comparison operator. If we build with the compiler from Microsoft, we are also going to get the same error and the error are going to be different, but the message is going to be the same. We are trying to use a deleted function. And if we want the compiler to use our equals and less than operators that we have in our integer type, we need to help the compiler out in telling it the kind of comparison that we support. So we're going to say that we want strong ordering again. Let's do that. And this is going to work if we build, for example, with Clang. We're going to get this to work. The build is going to be good as you see here. We are going to stop here in this lecture. In the next one, we're going to show you that it is also possible or necessary sometimes to do a custom three-way comparison operator if you don't want to do member-wise comparison with the default three-way comparison operator. So go ahead and finish up here and meet me in the next lecture.